No, a few people came in for help this morning, but I thought there would be more considering tomorrow is the test. Because for a lot of you, this test is like key. Because there's only 2 left in the quarter, you know. Now we got one more. When we come back from vacation. Actually, wait a minute. There's 2 more tests. Oh, semester. No, there is no semester test. There is going to be 2. Because there's going to be a test on just 7.2 all by itself.
What?
Oh, no. Sorry, there's only 1 more test after this one. Okay, 2D. Look, the test looks just like this. I know some of you still even haven't figured it out yet. This is what you have to do well on if you want to do well on the test. And you got to be able to do it by yourself without notes. 2D MRAM. Okay, I'm not going to write the chart again. Now, MRAM 3, you got to look at the number. That means you got to make 3 rectangles using the midpoint. So, from 0 to 60, if I divide that into 3 equal parts, each part is going to be what? 20. And then whatever the graph looks like if you want to plot points, the graph kind of looks like this, right? So, in problem 2D, we are using the midpoint to cap off the rectangle. Now, can you say that the base of each rectangle is always 20? Yeah, so why not factor out the 20? So, we have to use the midpoint. What's halfway between 0 and 20? 10. What is the y coordinate for 10? You have to look at the chart. You cannot simply just make up your own. You got to use the chart now. It's 3. 3. So that makes the first rectangle. What's halfway between 20 and 40? 30. So you look at the chart. What's the y coordinate for 30? 7. And then halfway between 40 and 60 is 50. Look at the chart. 13. Okay, so if you write that on your paper, you get 3 out of 4 points. You want the last point, you gotta compute it. Okay, number 3. Everybody can do number 3? Yeah.
I had a question about the MRAM and stuff. No matter how many you divide into, it's the same answer, right? As it should be.
No. So if I did MRAM, well, for this particular problem, I don't think I could give you anything else with the MRAM 3, but if I gave you more points, and if I ask you for MRAM 6, yeah, the answer's not going to be the same. Because you're making more rectangles, so it's going to be more accurate than this one. So the more rectangles you make, the more accurate you're going to be. Okay, number 4. 4E, there is no 4E, that's just 4.
No, it's the other.
There's a second 4.
What's second 4? There's no second 4.
After 7.
It's
There's
not
a-
4 and then 8. It's not.
Okay, you know what? Everybody can do number 4? You sure?
Yeah.
How come even on the BC test they got that one wrong? You know what? I'm going to do it on the video.
Is that part 1?
Yes. But I know already. I've been teaching this class for 30 years. Even though we've been saying it throughout the whole chapter, people are going to make the mistake, and it's going to be a fatal error. Okay, if you have a function that's an integral, how do you compute the derivative of this? You use the fundamental theorem of calculus, part 1. So what you do is first you make sure the lower limit is a constant. Check. Then all you have to do is take this and plug it in for t right there. So you get, how many times have I drawn that on the book? 1 over 1 minus cosine squared x. But then, the most important part is you gotta multiply it by the derivative of this, negative sine x. And then you gotta simplify that. So that's gonna be negative sine x over, hey, you somebody, sine squared x. This sine cancels one of those, so you get negative cosecant x. Now, I'm going to tell you tomorrow, if you do not multiply by the derivative of that, that is a fatal error. So this problem is going to be worth 5 points minus 5 right there. You need this. Otherwise, it's not the fundamental theorem of calculus. All right, number 5. Find the area. Okay, this problem is definitely on the test. Now, in order to find the area, you gotta draw this graph. Now, how do you graph polynomial functions? What do you do? Yeah, you gotta factor it so you can figure out the x-intercept. So how do you factor it when it's x cubed? You gotta use synthetic division. Now, I'm not gonna do that. You guys gonna do that on your own. If you use synthetic division, you will get this. See, but on the test, see, I'm gonna do that. Are you gonna actually go home and do it again if you didn't do it? Yeah, and then on the test you screw up and then you get a fatal error, right? That's what's gonna happen. So, -2 and 1 are the x-intercepts. If you want to put in the y-intercept of 2, you can. And it's a cubic polynomial, leading coefficient positive, so it looks like this. Doing. How come it bounced off that x-intercept? Because there's an even power. How come it went through this one? Because you had an odd power. All things from algebra 2 and pre-calculus, right? So what is the area bounded by the graph and the x-axis? Isn't it that area right there? Bounded means enclosed by. It has to be enclosed area. Because over here, it's not enclosed because it keeps on going up forever. It has to be enclosed by. So what integral represents this area right here? The integral from -2 to 1 of x cubed minus 3x plus 2 dx. And whenever you have a polynomial, that's the easiest functions to work with. The antiderivative, 1/4 x to the 4th minus 3/2 x squared plus 2x plus c, but again, we don't write the plus c because we know they cancel out. Plug in the top number, 1/4 minus 3/2 plus 2 minus plug in the bottom number, 16/4 is 4, minus 3/2 times 4 is 6, minus 4. So if you write that down on your paper, you will get everything except 1 point. 4 out of 5 points. You want the 5th point, you gotta compute that. Yeah.
When you put that bracket thing, the 1 and -2 on the antiderivative, would that mean it's equal to what's below it?
Yeah, this is equal to this is equal to that.
Oh, okay.
But I'm gonna train you when we get to the 4th quarter, when we train for the AP exam, don't put equal signs. Because if you put equal signs and they're not equal, then you kick off a point. Like for example, I know already without even looking at your work, some people are just not writing the dx. So if you don't write the dx and you put an equal, then they're not equal. It's only equal if you have the dx there. That would be a point off right there. See, when I do math on the board, I always do correct mathematics, but for some reason students, they don't follow that. They just make up their own. In fact, I bet some of you do this. Integral from 1 to -2. No, it's from -2 to 1. Even though I've been writing it that way on the board the whole time. But I know already, I've been teaching 30 years. That's what they do. That's what you do. All right, number 6. Okay, this is the meat of the test. Well, one meat of the test. Okay, so it's gonna be 4 points each. So then you have like a dozen of these. Now over here there's 16, but realistically tomorrow you're probably gonna have 10. Yeah, that's not enough to give you that many. So you gotta be able to finish, that's why, right? Yeah, but this is the same test they took like 20 years ago when they only had 42 minutes. What's the problem? 6C. Integral from 1 to 8. Okay, you wish you get something this easy tomorrow. Anytime you have x to the nth power, that's the easiest antiderivative there. Isn't this the same thing as x to the -1/3? Yeah, that's can't get easier than that. You make the power 1 bigger.
2/3.
Or is that the problem? You gotta make it 1 bigger. 2/3, and then you put the reciprocal in the front. That's the antiderivative. Plus c, well, we're not gonna write the plus c on a definite integral. Plug in the top number, 8 to the 2/3. You guys know how to compute 8 to the 2/3, right? Cube root it first, and then square it.
Oh.
What do you mean, oh? This is algebra 2.
It makes sense.
No way, this is review.
Because I
No
would
way.
always make it like 2 to the 3rd power and then cancel out the powers.
It's the same thing.
Yeah.
Yeah, but no way, this is review. You guys are like a blind man in a dark room looking for a black cat that's not there. No way. It's like a shot in the back. Did we get to that scene?
Yeah.
Oh, we saw them. Then you know what I'm talking about. Anyway, if you plug in 8, 8 to the 2/3 is 4. 4 times 3 halves is 6. Plug in the bottom number.
1.
It's 1 times 3 halves. And then I will leave the simplifying to you. Looks like 9 halves is the answer. Okay, D. D, where's D? Okay, I know the problem already. It's not the calculus, pre-calculus. E to the 2x, or maybe it is the
Oh, it's
calculus. What is the antiderivative of e to the 2x? Is it just e to the 2x? No, because I left a space in the front for the 1/2. How come there's a 1/2 there? Because the derivative of the box is 2, so you need a 1/2 to cancel out when you multiply by the derivative of the box. So whenever the derivative, see, like in most, like over here, the derivative of the box is 1, so you don't have to worry about it. But when the derivative of the box is not 1, you have to adjust for it by putting the reciprocal in the front. I guess you can put it in the back if you want. From 0 to natural log 5. Okay, here's the problem. Plug in the top number, 1/2 e to the 2 ln 5, minus, plug in the bottom number, e to the 0, everybody knows is 1, right? I hope. Okay, so that's 1/2. Okay, now if you left it like this tomorrow, I would have to take off at least 2 points. Because I'm telling you, on the AP exam, they're not going to write it like that. You've got to be able to pick out the answer on the multiple choice. How do you simplify something like this? Everybody knows e to the natural log banana is banana, right? So you got to make it look like that. So I have to get rid of this 2. Well, if you have a logarithm, what can you do with this 2 in the front? Put it up as the power. So e to the natural log banana is just banana, which is 25, right? So this is 25 halves minus 1/2. I think you can take it from there. Okay, I'm telling you right now that's on there. You gotta be able to handle that. Yeah, I know, but some of you guys just don't believe me or something. For real, it's like a half a year almost. G. Where's G? Okay. No! Okay, this is an insult. Is it pi over 2? Pi over 2. Cosecant. Okay, if you ask this question, then you simply don't know your list. Do you have the list of derivatives? You guys print it out so you guys. Okay, what's the antiderivative of cosecant squared x? This one is like no thinking. Negative cotangent x, right? Because the derivative of cotangent is negative cosecant squared.
It's the part. The one on the bottom is pi over 6.
So it is. Well, if you have good eyes.
I don't have it on my iPad.
I think it's glare on the board.
No, I just can't see. Okay, plug in the top number. Cotangent of pi over 2 is 0, so that's easy. Plug in the bottom number. Cotangent of pi over 6. Now, I don't know how how do you guys think of that? I just think tangent of pi over 6 is 1 over root 3, so cotangent is root 3, right? It's reciprocal. So negative root 3. I will leave the simplifying to you. H. Here we go. Does that say negative half to positive half? 1 over root 1 minus x squared dx. Okay, what's the antiderivative of that? Sine inverse x. It's right off the list. From negative half to a half. Was that the problem? Okay, don't answer me. Plug in the top number. Sine inverse half means sine of what angle is a half? Pi over 6. Plug in the bottom number. Sine of what angle is negative half, but the answer got to be in the range now. Remember the range? Negative pi over 6. Do not put 5 pi over 6 because, or 7 pi over 6 because that's not in the range. Now some of you went, what range? The range you learned in trig, pre-calculus, and the review that we did at the beginning of this year. That range. Yeah. Okay, for sine inverse, cosecant inverse, and tan inverse, it's from negative pi over 2 to pi over 2. For cosine inverse, secant inverse, and cotan inverse, it's from 0 to pi.
Oh, the C's and the Nazis.
The C's and the Nazis?
Are they
Oh my god.
No, they.
Oh, that's clever. That's clever. Are you in the Sound of Music? That's why?
Yes.
Oh yes.
That's why you make it. I get it, yes.
No.
What does the have to do with? Not the sine inverse.
Say that again?
Odd numbers.
Wait, time out. What's the question again?
You don't put a bracket on the left side. The sine inverse only on the right.
Oh yeah, that's just the way we do it in calculus.
Oh. So
Like if you have a number outside here, then you would close off the bracket, but otherwise, you just put the bracket. Well, how does the book do it? I don't know, I never looked at the book. This is standard notation. Some books actually just do this. They go boom, negative half to a half. They just put a line. But it doesn't matter.
I wrote down an I on the board, but I understand it now. So I don't know if anyone else wants to do that.
No, we need to do it.
Okay.
That problem's on the test. Even though we did this one how many times already. I think this was one of the first ones on that homework on whatever 6.4, when we first learned the fundamental theorem. What's the antiderivative of 2 to the x? 2 to the x over natural log 2. Again, how come? Because the derivative of 2 to the x is 2 to the x times natural log 2. So you need a natural log 2 on the bottom to cancel that one out. See, again, if you don't know the derivative, how can you do antiderivative? You cannot. That's why. You don't know your derivative is. From 0 to 2, and now it's easy. 4 over ln 2 minus 1 over ln 2. And don't make this mistake tomorrow, but I know it's going to happen already. If you plug in 0, you don't always get 0, you know.
I always.
Because some people, they see 0 on the bottom, they just put, oh, minus 0 then, but then no. And you get minus 2 right there, and then it adds up, you know. J, no J. Oh, good. K. Okay, now you're gonna have, I'll tell you, this problem is on there. We did it on the homework. I just kicked it up a notch here. Okay, so the first thing I mean, there's really nothing you can do right now, so you gotta multiply out the top. So what happens if I multiply out the top? You get x squared plus 2x plus 1 all over x squared dx. Now, I've been trying to train you. In fact, I remember we did it on the board when we did 6.4 homework. I remember. It was right about here. Lift and separate. Whenever you see a single term in the denominator, lift and separate. It's a common technique in calculus. So, what is x squared over x squared?
1.
What is 2x over x squared? 2 over x. And what is 1 over x squared? 1 over x squared. Okay, now we can find the antiderivative. We're in business. Okay, continuing on. So what's the antiderivative of 1? Okay, that one's easy. What's the antiderivative of 2 over x? Okay, let's come back to that one because some of you are befuddled. Now this one here is like x to the negative 2. So you make the power 1 bigger. Put the reciprocal in the front, so negative x to the negative 1. Oh, I get it now, Mr. Park. So this one is 2x to the negative 1. Make the power 1 bigger, 2x to the 0, and divide by the reciprocal. No! Someone's going, yeah, that looks good. No! You can't divide by 0. We did this on 2 natural log x.
Oh, yeah.
See, that one doesn't follow the rule. You cannot make the power 1 bigger. It's not. What's the derivative of natural log x? 1 over x.
Oh.
Yes, it's on the test. How else am I going to test you on if you know the antiderivative of 1 over x? It's going to be in this problem right here. From 2 to 4. Okay, plug in the top number, 4 plus 2 natural log 4 minus 1/4. Plug in the bottom number, 2 plus 2 ln 2 minus a half, and I will leave the simplifying to you. Can I trust you to simplify that?
No.
Are you serious? Okay, I don't know how you want to do this. Why don't we just go 4 plus 2, okay, right here, already. Let's have some foresight. 4 natural log 2. How is 2 natural log 4 the same thing as 4 natural log 2? Because 4 is 2 squared and you put the 2 in the front.
Oh.
Do we have to do that? No, yes. I'm gonna say yes. Because now you can add these two together. What is 4 natural log 2 minus 2 natural log 2? 2 natural log 2. Okay, and then the numbers you guys can take care of the number, right? Even though there's fractions there. Okay, too bad. If you can't do fractions, I'm sorry. Why am I sorry? You're sorry. 0 to pi over 2 sine x plus cosine x. Okay, you can't do anything with this. You cannot, there's nothing you can do. I hope you didn't do this. Do not ever do this. Oh, Mr. Park taught us that you just make the power 1 bigger, put the reciprocal in the front. No, because what about the derivative of the box? Oh, Mr. Park taught us to adjust for the derivative of box. Since you gotta times it by the derivative box, then you gotta divide by the derivative box, which would be cosine x minus sine x. Can I do that then? No, you can only do that when the derivative of the box is a constant, is a number. Because when it's not a number, is this going to work? If I take the derivative of this, will I get this? No, because you would have to use the quotient rule, and if you use the quotient rule on that, the thing is going to be so ugly, there's no way it's ever going to come out to that. So you can only do it when the derivative of the box is a constant. So no, bad dog. So what do? You got to multiply it out. That's the only thing you can do. Sine squared x plus 2 sine x cosine x. You know what? This problem, it wasn't on the test. I changed my mind. I'm going to put it on the test. I didn't write it yet. I'm going to write it during period 3 and 4. This problem is going to be on the test. Except I'm going to switch these two like that. And maybe put a minus in between. Is that, why not?
No.
Why not? What's the only thing different if that's a minus is that's a minus right there. It's not going to change anything except the answer. Look, if one little minus sign is going to throw you off, then that's just go home, cook rice. Okay, hey, sine squared x plus cosine squared x. Hey, use somebody. 1. And then 2 sine x cosine x. Use somebody. Sine 2x. So what's the difference if that's a 1 plus or a 1 minus? Come on, it's a matter of the negative sign. So now we take the antiderivative. What's the antiderivative of 1? That's easy. And what's the antiderivative of sine 2x? Is it just negative cosine 2x? No, because I left a space in the front for? No, 1/2. We're doing antiderivative. See, derivative, you would times it by 2. But when you do antiderivative, you have to adjust for the 2. You see the difference?
Oh.
We're doing antiderivative. From 0. So look, if that was a minus sign, the only difference is that would be a plus sign now. That's the only difference. Okay, I'll go one more step. Plug in the top number. You get pi over 2 minus cosine of pi is -1, so that's going to be plus 1/2. Minus, plug in 0. 0 minus cosine of 0 is 1, so minus 1/2. Okay. So it looks like pi over 2 plus 1 is the answer. Okay, Jack, right there, right there, IKL, that's 3 out of the 10 right there.
Mr. Park,
Yeah,
why is there a half before the cosine 2x?
because, okay, if I take the derivative of, okay, let's say, suppose you don't have the 1/2 there. Is the derivative of this that, what's the derivative of cosine 2x? Negative sine 2x times 2, right?
Oh.
See, because of this 2,
Oh, okay.
so that's why you need the 1/2 to cancel out that 2 over there. That's kind of big points too, you know. We've been doing it. Well, if you've been keeping up with the homework, we've been doing it. That's the problem though, isn't it? Okay, so that's the first meat of the test right there. Okay, we don't have to do 7. See, we did 7 so many times. You guys are good at it. I hope. Okay, number 4. Now the reason why this is number 4 is because I had to copy and paste this thing from the internet. And I couldn't, I guess I could have changed it a little bit. But that's okay. This problem is worth 20 points on tomorrow's test.
No.
It is.
Number what?
Number 4.
It's gonna, I'm pretty much
Oh, I
gonna be,
hate these.
it's gonna be like the same as the, when they gave it on the BC test. And then somebody said, oh, I forgot, I didn't study that one, and they got -18, so. Well, then how about studying it then? Because I told you this is 20 points. Well, they got 2 points at least. Okay, I'm gonna tell you right now, it's gonna be a semicircle with 2 line segments. It's just, I'm just gonna change it, like make it underneath or something. Because every year on the AP exam, this is, it's on there. Okay, so there's a semicircle of radius 2, 1, 2, so it goes up there. And then, in fact, this is like the one from the book, isn't it?
It's the one we did in class, kind of.
3. Oh, the example. 5, so whoop. No, no. Oh, it only goes to 4, that's why. See, I can't even see. It's a problem. Good there. So 4 from -3 to 4. Okay, I'm gonna tell you right now, part A, they only have 3 there, but tomorrow it's gonna be like 5. 1 point each, it's either 0 or 1. I'm trying to train you for the AP exam. You forget the negative sign, tough luck. Okay, G of 1. Okay, first of all, what's given? G of x equals the integral from 1 to x of f of t dt. Okay? And this is the graph of f right here. So G of x is this other graph that we don't know what it looks like, but we can infer things about it by using derivatives and things. Okay, G of 1. If this is G of x, how do I find G of 1? You simply plug in 1 for x right there. So the integral from 1 to 1. Now everybody better get this one tomorrow. This is the giveaway. It's 0. Any integral from any number to itself is 0. So that's going to be one of the 5, yes.
And so when are we supposed to write equal sign?
When they're equal.
Ah.
If oh, like for example, sometimes on the AP exam they ask you to write an equation that will solve this problem. You don't have to solve the equation, you gotta write an equation. Then you need an equal sign because that's what an equation is, right? But I'm gonna train you when you're doing computations, don't even put equal signs. Because if they're not equal, the point comes off. So like for example, okay, I'm not training you yet, but on the AP exam, then I will train you to just do this. So do your work like this. Okay, so this is the integral from 1 to 1 of f of t dt, 0. Just box it. See how doing it without writing equal signs?
So they wouldn't take off if you don't.
Yeah, they can't because you didn't write an equal sign.
Or no, like if you don't put an equal sign, will they mark you off because you didn't put the equal sign?
No.
Okay.
However, if they ask you, write an equation that will solve this problem, then it better be an equation. Because he said, write an equation. Like if you write this, x cubed, and then you don't write the right side, 3x plus 2. It doesn't even make sense. See? Now it's an equation. An equation has an equal sign in it. Okay, let's just continue. B, compute g of 3. So all you have to do now is plug in 3 for x. So 1 to 3 of f of t dt. So if this is the graph of f, what does the integral from 1 to 3 tell you?
The area.
The area between the graph and the x-axis right there. Well, 1/2 base times height. What is the base?
2.
What is the height?
1.
And it's below the x-axis. So it's negative, so the answer is -1. Uh-huh.
It says this graph is f of x, so when it's
Oh, don't let that confuse you. You can put any variable you want here. They're just putting the t here so that you don't get confused between the t and the x. but then we are confused, yeah?
Yeah.
Okay, they put the t here so that you can see that you're gonna use the fundamental theorem of calculus part 1 then.
Oh, I see.
Oh, 'cause
Because that's the way it's written in the fundamental theorem of part 1, huh?
It would look weird because you have like an X at the top and then you have.
Yeah, because you don't want to have this variable be the same as that, because that would even be more confusing. Yeah.
So the independent variable doesn't matter what it is?
Yeah, the independent variable, exactly, it doesn't matter.
So-
Okay, so if somebody were to ask you, what's the difference between this integral and this integral? Nothing. No, I'm sorry. What might be? Okay, how about this then? Okay, let's use different. Z. What's the difference between this integral and that integral? Nothing. They both mean the same thing.
Only the independent variable matters.
Yeah. Okay, moving on. C,
The little letter.
G of -1. See, so right now, if you forget that minus sign, it's wrong. I forget the number already. by saying that negative. Okay, so plug in -1 for x there, so you get the integral from 1 to -1 of f of t dt. Yeah, but Mr. Park, the smaller numbers stay on the top. We'll switch it then. So if you switch the limits in an integral, what has to happen? You gotta negate it to keep it the same. And if this is the graph of f, what does the integral from -1 to 1 tell you? The area between the graph and the x-axis. So that's equal to negative. So here's -1 and here's 1. We need to figure out that area right there. That's 1/4 of a circle of radius 2. Pi 2 squared, 4 pi divided by 4. It's pi, so it's negative pi because you have to switch the limits. So if you don't have that minus sign, I'm sorry, you got a 0. You just pulled a West Virginia. No, I'm serious. You guys don't believe me. It's only worth 1 point. So if you forget that minus sign, here, somebody in West Virginia did this. Shooting gaskets. You both got 0. I'm sorry, that's just the way it is, man. Okay, next. D. Find all values of x. Now, the interval, it's important now. Their interval is this. Okay, this is their interval. But on my test tomorrow, I'm going to tell you right now, it's going to be that. It's going to be including -3 and 4. So as soon as you see that, what are you thinking?
Oh, endpoint.
Endpoints. If you don't consider the endpoints, expect a lot of points to come off. So why don't we just do it with that, because that's how it's going to be tomorrow. So how do you determine when you have maximums and minimums? You take the derivative and you make a number line. So you need to compute the derivative of g. Now, here is g. How do you compute the derivative of g? How do you take the derivative of an integral? No, fundamental theorem of calculus part 1.
Oh, you plug it in.
You make sure the lower limit is a constant, and it will be. And then you gotta take this thing and plug it in there, so that's f of x times the derivative of that, which is 1. Please remember to multiply by the derivative of that, because that could cause everything else to be wrong already. Like I told you, in the book, it's always, most of the time it's 1, but it's not always gonna be 1. So if I'm gonna make a number line for g prime, I have to make a number line for f, because f is equal to g prime, right? So if this is the graph of f, that's g prime. So simply make a number line for this graph right here. Just make a number. So where does that graph touch the x-axis? -3, 1, and 3. Somebody came in for help this morning. They said, shouldn't I put 4 on the number line since it's an endpoint? No. No, you have to consider the endpoint. It doesn't belong on the number line because it doesn't cross the x-axis at 4, that's why. Okay, if it's above the x-axis, plus. Below, minus. Above, plus. That's what your number line should look like. G is increasing, G is decreasing, G is increasing. That's what you should have. So tell me, where do you have maximums? At 1 and 4. the endpoint. See, there's a maximum here, but since it's an endpoint, it's included, it's gonna be 4. So there would be, you would say there's maximums at x equal 1 and 4. Now, on the answer on the bottom, when he said 3, that's because it didn't include the endpoint. But I'm telling you, tomorrow it is. In fact, tomorrow, I'm gonna ask you, what is the absolute maximum?
Well, how do you do
You have to compute the y-coordinate here and the y-coordinate there. And that's gonna come from this part here. See, you already computed the y-coordinate at 1, it was 0. See, you did it over here, you just gotta compare. I'm gonna make you do it right here. So I'm gonna also ask you to compute g of 4. That's gonna be part of this. And then you just pick whichever one is bigger. You guys understand? Okay, where do you have minimums? Well, here at the endpoint, but there as well. So at x equal -3 and 3. What is the absolute minimum? So what you have to do is between these two, you gotta pick the smaller y-coordinate. Well, you already did one of them here, but tomorrow I'm gonna ask you to do the other one as well. And so, this one is -1, you gotta figure out what g of 3 is and just pick the smaller one. No, but yeah, well, Mr. Park, what if I didn't put the negative sign there? Yeah, so if you made a mistake here and you're trying to figure out which one is smaller, as long as you pick the smaller one of your 2 wrong answers, then you'll get that part correct at least. You know what I mean? Okay, what if they're both the same? Then they're both absolute minimums. Yeah, if they're the same. Okay, everybody understand this? So tomorrow, make sure you consider the endpoints. Okay, E, write the equation of the tangent line when x equals -1. So we know the x coordinate. You need 2 things to write. Good thing we're not going on to the next section. We're going to be in trouble. Okay, so you need a point and you need the slope, right? Okay, when x is -1, how do you figure out the y coordinate? Yeah, well, you did it. You did it right here. If I plug in -1 there, look, we did it. So, since you're using it again, as long as, even if you don't have the correct answer here, as long as you, whatever you got here, whatever it is, as long as you put it there, then you'll be fine. Because they're not going to penalize you twice for the same wrong answer. Now, how do you compute the slope of the tangent line? You got to plug -1 into the derivative. So where do I see the derivative? Right there. Here is g prime. So how do I compute g prime of -1? Well, that's equal to f of -1. This is the graph of f. How do I compute f of -1? When the x coordinate is -1, what is the y coordinate? It's 2. That is the slope. See how you gotta connect all the functions together using the fundamental theorem. Okay, and then of course, once you have the point and the slope, just do points don't form. Y plus pi equal 2 times x plus 1. Right there. You just leave it. Don't even put the pi on the other side. Just leave it. Mr. Park, this problem is long. That's why it's worth 20 points. Find all values of x where you have a point of inflection. Now, how do you find a point of inflection? Second derivative and make a number line. So, if g prime is equal to f, what is g double prime equal to? F prime. So, if I'm going to make a number line for g prime, I have to make a number line for f prime. Well, this is the graph of f. What is f prime? The derivative or the slope of this graph. So, where on this graph is the slope either 0 or doesn't exist? Well, over there it's 0. So -1 will go on there. But are there places where the derivative doesn't exist? In other words, sharp points? No, 1 and 3. Oh yeah, what am I talking about? 1 and 2. But also -3. You know why? Because look at the graph. What is the slope right there? It's undefined because it's like a vertical line, right? So, on your number line, you should have -3, -1, 1, and 2. Okay, now how do I fill in the numbers? Well, if a graph is going uphill, what can you say about the slopes? They're positive. Between -1 and 1, it's going downhill. The slopes are negative. Between 1 and 2, it's still going downhill, negative. Between 2 and 4, uphill, positive. That's how you figure out the science. Is the graph going uphill or downhill? That's all you gotta ask yourself. And what does this mean? G is concave up, G is concave down, G is concave down, G is concave up. I can do that because I have a legend. Now answer the question, where do you have points of inflection? Points of inflection at x equal what? Where does it change concavity? Negative 1 and 2. See, not 1 because it didn't change there. Okay, can you repeat this tomorrow? I hope so. Man, this is taking a long time. Moving on. Okay, where are we now? 8. Ah, you remember doing this one in the book? Mr. Parker tried to forget it. No, this is on the AP. Okay, the only reason I'm giving you this is because it's on the AP exam. Okay? If it wasn't on the AP exam, I wouldn't give you this. Because before, up until 2 years ago, it wasn't on the AP exam, so we never did it. But then now we're going to do it because it's on the AP exam again. Okay, write an integral for this Riemann sum. Now, if you have to draw the picture to help you draw the picture, okay, here's the x-axis. Okay, now. This 1/10 on the outside, what is that? That's the base of each rectangle. So that's like the biggest hint in the problem. This 1/10 here. That means the base of each rectangle is 1/10. So however many rectangles you make, each one is 1/10. That's what that is. Okay, now I'm going to tell you right now that anytime they give you a Riemann sum like this, they're doing a right endpoint Riemann sum. They're doing an R-rem. Okay? So since the first one is 1/10 right there, that means this one got to be 0 then, right? Because the width. Okay, and then the next one is 2/10, 3/10, and you just keep on going until you hit 30/10, which of course is 3, right? So already, you know your integrals are going to go from 0 to 3 already, just from doing that. Now all you have to do is figure out what function is it. Now, whatever the graph is, whatever the function is, look, you split it up into these rectangles like that. If you use the right endpoint Riemann sum like that, like that, doesn't the height of the first rectangle, isn't the height of the first rectangle simply the y coordinate at this point? So if the x coordinate is 1/10, what function do I have to plug it into so I get this as the y coordinate? Isn't it just x squared? Because if you plug 1/10 into x squared, don't you get that? And then the second rectangle, isn't the y coordinate of that point the height of the rectangle? So 2/10, what do I have to plug 2/10 into to get this? See how all of them are squared? That tells you what function it is. So it's x squared dx. That's your answer. So tomorrow, what if I changed it a little bit? What if I went 40 over 10 squared? Yeah, then that would mean it goes 0 to 4 then, yeah. What if I change this to, what if I change all of these to 5th power like that? 5th power, 5th power, 5th power. That just means x to the 5th. Can do? Okay, hopefully we'll see about that. Number 9. Okay, this is the one I showed you yesterday. Obviously that wasn't enough. Okay, so I'm telling you right now, you are going to use a double angle like that if you choose to do this problem. Or you're just going to take the -6. What? -6? That's because you're going to do plenty of work, people. Okay, so this is the area. Okay, that's the area you need to find. I'm gonna actually give you the graph to you. And I'm gonna even actually shade in the region. It's gonna look something like that. Here is the graph. Yeah, but see, if you think about it, I have to give you the graph because how do you know if I want that area or this area there? You don't know, right? So that's why I gotta show you which area I want. Okay, so what you gotta do is you gotta figure out these x-intercepts so that you know your limits of integration. So how do you do that? How do you find x-intercepts of the graph? Set y equal to 0 and solve this equation. So when you solve this equation, you gotta use double angle identity. What happens if you use the wrong one tomorrow? Oh gosh, that might be. Okay, sine 2x. Okay. Factor out cosine. So you get 2 sine x minus 1. Okay, so either cosine x equals 0 or sine x equals 1/2. Cosine of what angle is 0? Pi over 2, 3 pi over 2. Sine of what angle is 1/2? Okay. Yeah, how come you guys know it today? So tell me, look, what is that first one right there? Wouldn't that be pi over 6? What is the next x-intercept? Pi over 2 is the next one. And then what's the next one? 5 pi over 6. And then 3 pi over 2 is that one over there. So, since I'm asking you to find this area, the integral is going to go to 5 pi over 6 to 3 pi over 2 of sine 2x minus cosine x dx. This integral represents that area. Okay, so tomorrow, what if I ask you for that area? Then you go from pi over 6 to pi over 2. And remember, area is not negative now. No such thing as negative area. And integral can be negative, but area cannot be negative. I'll just go one more step. So, antiderivative of this. Is the antiderivative of sine 2x just negative cosine 2x? No, because I left the space for the 1/2. And is the antiderivative of cosine x just sine x? Yes, because I didn't leave a space. Oh. 5 pi over 6 to 3 pi over 2. You know what? In the interest of time, you guys got to take it from there. I know you guys have problems with trig values, but come on. This the 3 years of trigonometry study. And then you go to college next year? You think the summer's going to save you? No, you still got to know trig. When you go to college, I would suggest you take the, I'm going to give you a cheat sheet, you know, in the 4th quarter. Take that cheat sheet with you to college. Why don't you Xerox so you can sell it to other students? For real. Yeah. Don't give it to them, sell it. Okay, this is the problem I was telling you about, cold bread. Remember that?
No.
Okay, this is the only problem that you're going to use your calculator on tomorrow. This is the only one. Are you saying I have to bring a calculator? Yes! For this particular problem. X of 1 is equal to 2. Compute x of 4. Okay, Mr. Park, I don't get when to use code red. If they give you a function and they ask you something about its antiderivative, that's when you use code red. See, because this is the velocity. Isn't the position the antiderivative of velocity? Okay, so what am I going to do here? I'm going to integrate the velocity. This is the velocity. From, what limits do I put on? 1 to 4. How do I know 1 to 4? Because one of them you know and the other one you're trying to find. Okay, so how do I compute that? Well, if this is the velocity, so how do you compute any integral? You find the antiderivative of it. What's the antiderivative of velocity? Position, which is x. X is the position. You plug in the top number, you plug in the bottom number, and you subtract. That's the fundamental theorem of calculus part 2. But like I said, we don't like to say that it's too many words. We just say code red. So, do we know what this is?
Yes.
That's 2. Can I compute this on my calculator?
Yes.
Yes. Well, not probably. Yes. So all you have to do to compute this one is add 2.